is to represent information from real situations in the form of matrices. Okay, so first is the definition. What does it mean by matrix? Matrix, from your textbook, it is a set of numbers arranged in rows and columns to form a rectangular or a square array. Okay, look at here. So it is common. It's common for us to see table like this. Okay, table. So you have a fan in store online. Okay, so stand fan, ceiling fan, wall fan. Okay, so in store and online. So this one I got from your textbook, page 36. Okay, so if you want to transform from table to matrix form, we just take out the numbers in order lah. So 16 followed by 18 followed by 11, and then for the second row 5, 10, 4. Okay, so all the numbers must stay put at their position. Okay, so that they are in their respective columns and their respective row. For the second table, gold, silver, bronze, diving, pencaksilat, athletics. So the first row is for diving, second row is for pencaksilat, and the third row is for athletics. Okay, and for the gold, how many gold, how many silver, how many bronze they got. The medal collection of Malaysian contingent for 3 events in the 2019 SEA Games. Okay, so from the second table here, when we transform it into matrix form, so we take out the numbers again. So we got 13, 5, 1. Okay, 13, 5 and 1, 10, 2, 4, 8, 8, 9. Okay, so next, the column matrix, row matrix and square matrix. Okay, so column matrix is when you have a matrix like a vertical just column. Okay, just one column. So you have you can have as many rows that, as you want, but as long as the number of column is only 1. So for the row matrix, the number of row is only 1. Okay, so for example here, I have a column matrix. The first 4, 7, 9, 27, and the third 1 to 100, 208. Okay, so here is a column matrix. Okay, column matrix has only one column. So for the row matrix here, I have 2 examples, negative 2, 2, and 800, 7, 6, 8, and 1000. Okay, so if you can see here, I use square bracket as well as the usual bracket. Okay, so I can use square bracket, I can use the usual bracket that we usually use lah. Next, the square matrix. Square matrix, what does it mean by square? Is when you have a rectangle with equal length of the length and the width. Okay, so meaning you have the same number of columns and rows. Okay, a rectangular matrix with the same number of rows and columns, we call it a square matrix. Good. Okay, so let's move on to 2.1.2. To determine the order of a matrix. The order hence identify certain elements in a matrix. Okay, what does it mean by the order of a matrix? Okay, matrix with m rows and n columns has the order m by n. Okay, so let me show you an example. Okay, let's say I have here negative 2, 0, 1, 5, 4, 9. This is a matrix. Matrix A, give it a name, matrix A. Okay, so here the order is the number of row and the number of columns. How many rows? 1, 2, 3. 3 rows by how many columns? 1, 2. So the order of this matrix A is 3 by 2. Okay, and all the numbers inside the matrix, we call them as elements. Okay, elements, 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 elements. Okay, so the negative 2 is an element of matrix A. Okay, the capital A. Okay, we usually denoted matrix by using capital letter. Okay, capital letter. So negative 2 is an element in matrix A. So denoted by A, the first row and first column, A1 1. Okay, so what is the value for A3 2? So A32 means the elements of the third row second column. Third row second column. So A32 is equals to 9. Okay, so the formula is actually Aij here. If you can see Aij. Okay, the first is the row and the second is the column. Okay, element order. Okay, so we are done with this page. So I hope you can understand. So let's try an example. What other example do you want to try? Just make up another matrix. Okay, black matrix E. Okay, matrix E is a matrix 4 9 3 1 0 1 0 2. Okay, so matrix E, what's the order of matrix E? The order of matrix E is how many rows? 2 rows. How many columns? 4 columns. Is 2 by 4. Okay, it's 2 by 4. Okay, identify the elements in matrix E. Identifying elements. E. So the small e, E2 3, E2 2, E1 4. Okay, since we are using the capital letter E, so the elements we use the small letter E. So E2 3, second row and third column. Second row, third column. So here, okay, 0. Next, second row, second column. Second row, second column, 1. First row, fourth column. First row, fourth column, 1. Okay, so that's how we identify the elements of a matrix. Okay, next, move on. Determine whether two matrices are equal. Okay, this one is easy. Okay, it's much easier. Why? Okay, let's look here. What does it mean by equal matrices? Okay, by definition, two matrices are the same if they have the same dimension and every element of the one is the same as every element in the other. Okay, by the way, dimension is another way to say the order. Okay, the order Sometimes you call it the element, the dimension. Okay, dimension. The dimensions are the same. Okay, so let's look here. Matrix A 2 3 negative 1 5, B 2 3 negative 1 5. So all elements are the same. So we say that matrix A is equal to matrix B. Okay, next we have an exercise here. Determine whether each of the following pairs of matrices is equal. Give your reason. Okay, the first one, a matrix of 2 11 1 3 and 2 11 1 3, A and B are both the same. We can just directly see. It's obvious. Okay, for question B, matrix C we have 3 9, matrix D also we have 3 9. The thing is, matrix C is a row matrix, matrix D is a column matrix. So can we say these two matrices are equal? Are they equal? They are not. Why they are not equal? Because the order are different. So let's look here. Matrix C we have 3 9. Matrix D we have 3 9. One is a matrix of order 1 by 2, and this one is another matrix of order 2 by 1. Okay, usually we write the order of the matrix at the bottom corner right, right bottom corner. Okay, so 1 by 2, 2 by 1. So here it shows that these two matrices are not equal. So C does not equal to D. Okay, next, add and subtract matrices, multiply a matrix by a number and multiply two matrices. Okay, let me tell you the 2.2.1, 2.2.2, these two are easy. So trust me, even though the definition looks like a bit complicated because of all the notations and the subscript, okay, but actually these things are easy. Okay, here's the definition. Addition and subtraction of matrices can only be performed on the matrices with the same order. Okay, each corresponding element is added or subtracted to obtain a single matrix with the same order. Okay, let's say you have a matrix here, a matrix of order 2 by 3. Okay, so we do the addition. So 16 plus 20 equals to 36, 18 plus 15 equals to 33. So it's just a simple addition. Same goes to subtraction. It's just a simple subtraction. It's just you have the brackets, okay, and you put the numbers at their respective places. Okay, if it's the element of the first row and the third column, just put it in the first row and the third column. Okay, don't put it somewhere else. Okay. So that's the simple part of addition and subtraction. So let's go for a bit challenging example. Just a little bit challenging. Example here, matrix D, matrix E, and the D plus E is that's 8, negative 1, negative 5, 13. Calculate the values of X and Y. Okay, I have the solution here, but I would prefer to show you my own working. Okay, so okay, what was it just now? Matrix D and E. The D is 2x minus 1, negative 12, negative 3, 5 plus y. This is the D. And the E, x to 7y. The D plus E equals to 8, negative 5, negative 1, 13. Okay, so you know that the 2x minus 1 plus x equals to 8. Okay, the 5 plus y equals to 13. So that's easy. The 2x minus 1 plus x equals to 8. 3x minus 1 equals to 8 plus 1, 9 over 3x, x equals to 3. Simple, right? And for the y, we can see that 5 plus y equals to 13. So give it a go. 5 plus y equals to 13. 2y equals to 13 minus 5 equals to 8 over 2 equals to 4. X equals to 3, y equals to 4. So it's very simple. Okay, next we move to how to multiply a matrix by a number. Okay, again, the simple part. We love the simple part, right? Okay, matrix D is negative 5, 2, 4, 1. Calculate 3D. So 3D is actually 3 times negative 5, 2, 4, 1. Okay, the number 3 outside the matrix is to be multiplied with all the elements inside the matrix. So 3D, negative 15, 6, 12 and 3. So that's the answer. Simple. Okay, calculate negative 1 over 2D, negative 1 over 2D, negative 1 over 2 times the matrix D. So 5 over 2, negative 1, negative 2, negative 1 over 2. And don't forget the square bracket. Okay, good. Okay, another thing, when we multiply a matrix by a number, we call it as scalar multiplication. This is what we call scalar multiplication. What does it mean by scalar? Scalar is the real number. Is the real number that is multiplied with a matrix. Okay, so a real number, when you multiply with a matrix, we call that real number as scalar. Okay, so this thing here is scalar. Why? Because it's going to be multiplied with a matrix. So next, what do we have next? Multiply two matrices. Okay, so here is the thing for today. How do we multiply two matrices? Okay, so first let's learn the definition. Okay, if matrix A has an order of m by n and matrix B has an order of n by p, then the multiplication AB can be performed and the order of AB is m by p. Did you get that? n by p is the order of the product of matrix A and B. Okay. So what does it mean? Is actually when you want to multiply two matrices, so you need to make sure the first matrix and the second matrix, the dimension, okay, their dimensions are important. Here the dimension is n by n, p n by p. There's two things. The n must be the same. Okay, here must be n must be the same number. Okay, so for example, you have you have 2 by 3 and 3 by 1. So you can multiply these two matrices. So you're going to get a product matrix AB. The answer is, what is the order of matrix AB? 2 by 1. Okay, when you multiply A times B, you're going to get a matrix of order 2 by 1. So let's say you have a square matrix 2 by 2 and 2 by 2. So can we multiply these two matrices, a 2 by 2 matrix and a 2 by 2 matrix? Of course. So what's the order of the product of these two matrices? So the order is, since these two are the same, so the order is 2 by 2. So A 2 by 2 times B 2 by 2. So you're going to get a matrix AB of order 2 by 2. Okay, remember, just now here we have 2 by 3 and 3 by 1. So the order is 2 by 1, the product. Okay, so this is important. Okay, so let's get back to our notes. Okay, a further explanation here is given that matrix C and matrix D here, determine whether multiplication CD and DC can be performed. If yes, state the order of the product of the matrices. Okay, CD. Okay, the C multiply the C matrix multiply the D matrix. So 2 by 1 and 2 by 2, the number of column and the number of column of matrix C is different from the number of row of matrix D. Okay, 1 and 2 are two different numbers, so we cannot multiply CD, but we can multiply DC. Why? Because the number of column in matrix D is the same as the number of rows in matrix C, so we can multiply DC. Okay, it's important in multiplying matrices. So the order is important. I mean, which matrix come first? Okay, so AB is not necessarily in general equal to BA. Okay, because let's look here. Okay, here we have a matrix A of order 2 by 3 and B of order 3 by 1. So what if I'm going to multiply BA? What happened? So B is a matrix of order 3 by 1 and A order is 2 by 3. Okay, can you see these two are different? So we cannot multiply B times A. Cannot multiply these two. Why? Because when B comes first, the number of columns of B is not equal to the number of rows in A. But when A comes first, oops, was it black? When A comes first, the number of columns of matrix A is the same as the number of rows in matrix B. Okay, can you get that? Yeah, you need some time to brain this. Okay, take your time. Okay, let me continue. Okay, take your time. Let me continue. Let me get an example, a good example for you. Okay, here's an example. Okay, this one I got from your textbook, page 51. Okay, so why is it important? Number of rows of the first the number of columns of the first matrix is the same as the number of rows in the second matrix. Because of this, we want to multiply the elements of it. Okay, so look, the green one, 2, 3, to be multiplied with 6, negative 2. Okay, so 2 times 6, 3 times negative 2. Okay, next, we go to the second column of the second matrix. So we are still in the first row for the first matrix. Okay, so 2, 3 multiplied by negative 7, 1. So that's the product is the element of the first row and second column. Okay, so okay, look at this this working solution. So that's how you multiply matrices. Okay, so let me do mine. Okay, here. So we have okay, we have 2, 3, 1, 5, and to be multiplied with 6, negative 7, negative 2, 1. Okay, first, it's not a good idea to use a yellow pen. Okay, let me rewrite by using black pen. Negative 2, negative 7, 1. Okay, so here I have 2, 3 and 6, negative 2. Okay, first row, first column. So first row, first column, I have 2 times 6 plus 3 times negative 2. Okay, next I have first row. Let me use. I have first row and the second column. So 2, negative 7 plus 3 times 1. Okay, next, the second row and the first column of our answer is 1 times 6 plus 5 times negative 2. And the second row, second column of our answer is, okay, let's choose other color here. Second row and second column, so it is 1 times negative 7 plus 5 times 1. Okay, can you see that? Again, we need the bracket. Okay, since you are working with matrices. So 2, 6, 12, 12 plus negative 6 is 6. Negative 14 plus 3, negative 11. 6 minus 10, negative 4. Negative 7 plus 5, negative 2. So here is the answer. Okay, can you see that? We have here 2 by 2 and 2 by 2. So we can multiply since these two are equal. So our answer will be 2 by 2. So here is the 2 by 2. And yeah, that's how we did it. Okay.